Hello everyone and welcome to this video presentation. My name is Tarun Karthikeyan from class 5 BSc and today I am presenting my end-to-end practical project for our business intelligence course. The primary objective of this project is to build fully interactive production-ready business intelligence dashboards in Microsoft Power BI across two distinct business domains, agricultural yield analytics and IPL sports performance analytics. Over the next few minutes, I will guide you through the business goals, data models, custom DAX formulas, interactive chart findings, and strategic recommendations for both domains. Let us begin with our first domain, agricultural yield analytics. The main objective of this dashboard is to analyze observational data across 10,000 agricultural plots to understand what drives crop yields, evaluate soil performance across regions, and optimize farming decisions like fertilizer use and irrigation. The dashboard serves three specific user groups. First, agricultural operation managers who monitor seasonal harvesting performance across farms. Second, agronomists and soil scientists who analyze physical soil textures like sandy, silty, clayey, and loamy soils along with their pH levels and vegetation health. And third, supply chain executives who need yield predictions to organize grain distribution and protect against crop loss. Now let us look at the underlying data architecture in model view. To ensure fast calculation and proper reporting, I structured the dataset using a star schema data model. Our central fact table is agricultural yield prediction, which contains 10,000 plot records. This fact table connects in a one-to-many relationship to a date dimension table named dim date. I also created a dedicated container table called measures to keep all calculated fields neat and organized. To calculate our key metrics dynamically, I wrote custom data analysis expressions, which is called DAX. First, to compute overall farm output, I wrote the average yield measure, which is this one, average of yield predictions per year. And next, for calculating high yield rate, I used this formula. Using explicit DAX ensures that all calculations instantly adjust whenever a user applies a filter. Returning to the report view, let us review our baseline global key performance indicators across all 10,000 plots. So this is our baseline global key performance indicators across 10,000 plots. And here we can see that the global average yield is 5.47 metric ton per hectare and total sample size is exactly 10,000 plots and the high yield success rate is 28.23 of all plots produced optimal yield outputs above 6 tons per hectare. And the NDVI is 0, which is the normalist difference vegetation index average. Looking at our clustered bar chart, this is the clustered bar chart. Here, the chart breaks down soil performance by region. In the east region, sandy soil yields the highest at 5.61 tons per hectare, while the loamy soil lags at 5.39. In the north region, silty loamy soil lags at 5.39. In the north region, silty soil leads at 5.46. In the south region, silty soil reaches 5.46. In the south region, silty soil reaches 5.61 ton hectares. And in the west region, loamy soil performs best at 5.54 tons per hectare. Now let us test the interactive power of this dashboard by applying filters. I will select East region in the region slicer and maize in the crop type slicer. Notice how all visualizations change instantly. It filters down to 645 plots. The average yield drops from our global 5.7 baseline to the 5.34 metric tons per hectare. The high yield success rate fails from 28.23 to 27.60. Most importantly, looking at the soil breakdown, loamy soil underperforms severely for maize in the east, yielding only 5.15 tons per hectare. Meanwhile, clayey soil performs best for the maize in this region at 5.47 tons per hectare. Based on this finding, we recommend two clear business actions. First, field agronomists should prioritize soil treatment and organic conditioning on loamy soil plots, growing maize in the east region to raise their performance from 5.15 back up to towards the 5.47 average. Second, farm operations should roll out precision irrigation and targeted fertilizers application to mid-tier plots, helping push our global high yield rate from 28.23 towards 35%. Now let us switch to our second business domain, IPL sports performance analytics. The goal of this dashboard is to transform ball by ball tournament data from 1,000 IPL matches into a strategic sport intelligence to evaluate team success, player auction efficiency, venue scoring targets, and match strategies. This sports dashboard targets three key stakeholder groups. First, the franchise owners and auction strategists who evaluate player cost efficiency to spend their auction budget wisely. Second, head coaches and team analysis who build match winning tactics using venue target history and toss trends. And third, broadcasters and media analysts who use data driven stats during match commentary. Let us inspect the data structure in model view. Unlike our first project, this post dashboard requires a dual fact star schema. We have two primary fact tables, which is matches which stores high level match results like the winner, venue, toss, choice, and season, and the deliveries which stores granular ball by ball events like runs, extras, and wickets. Both fact tables connect on a match ID in a one to many relationship link directly to dimension tables for seasons and players. To calculate scoring dynamics dynamically across team and venues, I engineered explicit DAX measures. To sum up the total tournament runs, I wrote total run scores is equal to sum of deliveries of each run. And for total wickets, I had this formula for the total wickets. These formulas allows us to slice performance from high level seasons total down to individual match deliveries. Returning to the overview report, let us analyze our baseline tournament metrics across all 1000 historical matches. Exactly 1000 matches are analyzed, over which the total runs scored is 3,13,000 and total sixes cleared were 14,000 and the total wickets taken are 7,000. Peak player auction valuation is in 23.8 crores, representing the highest individual player purchase. Let us perform a franchise deep dive by selecting Chennai Super Kings in our team slicer. The dashboard updates to the show that CSK participated in 129 matches, accumulating 34,000 runs, 2,006s, and 830 wickets. Now examine our scatter plot comparing player auction price against total runs scored. While the top tier marquee player costing 15 to 28, 23.8 crores score high runs totals, the scatter plot reveals valuable opportunities and several mid-tier players priced between 4 crores and 8 crores produce total run values comparable to marquee players who are bought from 15 to 23.8 crores. This highlights clear value opportunities for auction strategies. Now let us analyze our toss decision, analyze match strategy visuals. Looking at our donut decision chart across all 1000 matches, teams winning the toss selected to field first in 53.2 of the matches compared to batting first. Like they have won 53.2% of the matches batting first compared to like fielding first compared to batting first. Finally, look at the venue target column chart comparing first inning targets and against second inning target. Scores across major venues like Hyderabad, Delhi, Mohali, and Nagpur across almost every venue, first inning scores consistently beat second innings chase averages, proving the strong impact of scoreboard pressure during chases. From these insights, we recommend two key strategies. First batting because first innings totals regularly beat second innings chase averages across venues. Teams chasing targets should focus on preserving wickets during middle overs to manage required run rates effectively. Second, franchise auctions franchise auction teams should use our cost efficiency scatter plot to target undervalued mid-tier players to the in the 4 to 8 crore bracket, saving auction process first budget to bid for top death over bowlers. To summarize our business intelligence methodology across both projects, agriculture uses a single fact star schema for plot summaries, while IPL Sports uses a dual fact star schema connecting match metadata with delivery logs. Agriculture measures seasonal plot outputs, whereas IPL measures high frequency ball by ball event. Agriculture filters across regions, soil textures, and crop types, while IPL filters across teams, seasons, venues, and auction prices. Business value: agriculture drives soil management and crop yield optimization, while sports BI drives auction budget optimization and match tactics. In conclusion, this project demonstrates how business intelligence tools like Microsoft Power BI, supported by proper relational modeling and tax formulas, can convert complex data from entirely different industries into clear, actionable business strategies. Thank you very much for watching this presentation.